according to the standards. Now in these examples, I'm going to use just 3 voltages. If you look at what I have selected, I'm using 22 kV as a distribution level. And then say it goes down to 6.6, assuming I have some medium voltage motors connected to it. And then further down to the LV system. So once I click OK, I can start the modeling. You always start from the utility source, whether from the generator, power grid models, or even a wind turbine. So I'm going to start with a utility source. Okay. And then it goes according to your selection. So basically, what is the next element connected to these models? You can simply just connect. Now, ETAP has a very advanced algorithm. It tells the program, the program basically allows us to look at what are the available elements can be connected to this utility models. For example, I won't be able to click on the motor elements. I won't be able to connect another utility models to this. So it enable elements that suitable to be connected based on your reference elements, in this case, our utility. So I will do a very quick demonstration right now to show you how ETAP Auto Build works. So I can have a cable here. And then say I have a high voltage breakers and it goes to a consumer substation, for example, in this case, 22 kV. I can have another high voltage breaker, which bring the voltage down to a medium voltage. So as you can see, it goes according to your selection. We have selected 22 kV, 6.6, and so on. I mean, if you want to continue to bring down the voltage to LV, you can continue from 6.6, or if you are having a transformer which step down from 22 kV, you can go back to the 22 kV bus, add in another breaker, for example, choose the 2-winding transformer, and specify the voltage that you want to be connected right after the secondary side of this transformer. So in this case, if I don't want to have a 6.6 kV switchgear, after this, I can choose the voltage I want and then put in the breaker and the bus bar accordingly. Now, if you want to have a DC system also in your modeling, you can continue from here because we have a DC equipment as well as the instrumentation elements for you. So assuming it goes to another sub board. So I will put another sub board here just to represent another bus. And then I can have a charger to convert from AC to DC, or a rectifier. So that goes this way. And some DC load, for example. So as you can see right now, I probably spent just 2 minutes, and this model is easily being set up based on the auto build features. Say editing the one-eye diagram is pretty straightforward. You can extend the bus. You can move the entire network. If you want to continue with your 6.6 kV system, you can go back to the 6.6 kV bus. Say, for example, I have a medium voltage motors. You can add one in. If you want more, you can continue. You can continue with the numbers of components that you want. Now, also, if you say, for example, if you miss out something in the model, you wanted to add a breaker for the motor feeder. You can always go back to this motor, select the breaker you want, and maybe the equipment cable as well. Okay, that's how it works in ETAP for auto build. Now let me introduce you another elements in ETAP we call composite network. If for some reason, if you want to create a subsystem within the one-eye diagram, you can always use the composite network or a MCC, for example. So I can rename this as my DC system, for example, and bring this entire network inside my composite network. So that I have two windows here. One window shows the composite network. Another windows basically shows the overall one-eye diagram. So I can reconnect this and then put this back in service. Okay. I'll talk more about the check circuit continuity later on when we look at the configuration setup. Okay, so that's how it works if for this subsystem. Now, whenever you double click on any of the elements, you are actually open up the editors for these utility elements. For example, it has different tab for you to fill in the data depending on your calculation requirements. Say, for example, if you wanted to run a load flow calculation for your system, you may not need to key in the short circuit parameters of the prospective fault KA at the point of connection. So you can skip all this. You can go into another elements, specify your transformer MVA, for example. What is your transformer impedance? Or you can also use some typical values available in ETAP according to the standards. As for the library, ETAP provide a very comprehensive library, not only for cable, we have library for breakers, relay as well. So if I were to choose a cable from the library, I can simply go into this cable editor, hit on the library buttons. As you can see from the windows pop up here, ETAP right now, you have almost 600 over entries for you to choose. And filter options are available. For example, I would like to look at just for a three core cable in this case. A 50 Hz system, a copper, based on metric system, and perhaps the last one, because this is a 6.6 kV, I can choose this. And you see the program basically narrow down your selection. So right now you only left two based on BS standard from different manufacturer. So you can pick one of these, choose the cable size you want, and specify the length. Those data from the impedance page are being imported from the library. Now the same thing apply to breakers. You can look at the libraries depending on the manufacturers. Say for example, Schneider. We can have a list of different models based on manufacturer. So you can pick accordingly. Now, I won't spend too much time to go through the data entry because probably spend more time to look at the analysis rather than this. So what I would do is I'll go back to my example files. Now, you can delete it away from your project, or you can simply, in this case, I will just put this out of service so that it doesn't take this in when I run the calculation for this model. Now, going back to this model, assuming we have done the modeling part, you have the model, uh, you have your model up, you have this utility connection, you have all the components or all the equipments that you want in your study. Now, the next thing is always very challenging because we usually don't run a load flow just based on what I have here. We may want to consider many different configuration, different system topology. Hold on, I think is somebody trying to enter? Okay, no. Okay. It depends on it depends on how many scenarios that you want to consider in your calculations. Say, for example, you may want to consider generator running in parallel with utility. You may want to consider what happens if one of the transformer is down for maintenance. Or you may want to consider there is a fault happen at the renewable system. So the whole DC system is get affected. So to do that, that's where the configuration, ETAP configurations will be able to help to manage different operating topology. You may also want to consider what happens if I don't run certain motors. Or maybe you want to have different loading criteria. For example, maybe traction simulation, you may have loads at morning, uh, maybe peak load conditions, or maybe you want to consider what happens if it's during school holiday, where a lot of people are coming out, to for leisure. So all these need to be pre-configured in ETAP, either through configuration manager or through the design study case. Let me quickly touch on what is the loading criteria here, loading categories or generation category. Like I mentioned just now, if you want to consider motor 1 running or motor 2 not running based on certain configuration, you can manage your loading criteria in your study case. The same apply to your generation category. If your utility, very often, sometimes we don't get the voltage 100% at the nominal at your point of interconnection. So if you want to consider what happens if the voltage is up 5% or down 5% in your simulation, all this can be done through the through this study case. A very quick one to show you where are the loading categories. You can change the name of your loading category, but by default, this is what you get. You can specify if the motor is running at 100% or 50% or not, or no load condition. For the generation, we have different category as well. You can run at 3% below your nominal or 3% more than your nominal. So all these are configurable. Now going back to the configuration in ETAP, by default you will have a normal configuration. Now in this case, right, if you look at this example, what is this normal configuration represent? It basically tells us the coupler between the switchboard A and switchboard B or bus B is open. The the filter is right now not connected. If I switch to another configuration, say for example gen off, it is clearly indicate that the generator right now, you see the breaker is in open position. The entire system from start from the wind turbine all the way down to your DC system, they are not in service as well, not part of the calculation. So they basically identify what we have configured for different system topology. Of course, if you want to have another one, you can always go to the configuration status. You can add one, you can copy, you can add a new one. That's very easy. Now, having said that, um, you notice right now I have a list of different configuration. Assuming if I want to run a load flow based on this configuration, um, I can simply hit the run load flow calculation. Now that basically gives us some results based on the normal configuration. I'll just quickly go through what it means from the simulated results from the one line diagram. The percentage indicated right next to the bus bar represent the steady state voltage profile for the percentage of the nominal voltage. Right? You can change to kV if you want. You can turn on the units. But right now, the current flow it shows the current flow from utility all the way down to the single phase system. There is a buttons here for us to toggle what we want to display. If you want to see kilowatt and kilovolt, you can change accordingly. Now, what's so good about this 3D dimensional database in ETAP? If I were to repeat the same thing, you notice it's going to be very troublesome. Say I want to run a gen off condition, I need to keep on changing the drop down list based on what I want. So in order to consolidate the configuration as well as the loading criteria, we can also utilize the scenario wizard, which allows us to put all this together within one scenario. So for example, I have a scenario for the load flow. Let me choose one. Uh, where is the load flow? Let me see. Okay, the load flow. Say for example, if I want to run a load flow for design, I can simply choose the design scenario and it bring back all the configuration that I have done for this scenario. It basically means I want to run this scenario based on design criteria, based on normal operating configuration. And I'll talk about the revision later on when we look at the short circuit calculation. So you can run it through the scenario wizard, or you can run from the drop down list here. Now ETAP provides us something what we call load flow analyzer. Now this load flow analyzer basically help us to look at all the reports that we generate from different scenario. As you can see right now from this report, it tells us it, from a summary tabulated um, windows, we will be able to easily identify based on different scenario that I have, which scenario actually result in the highest voltage drop. So as you can see right now from this table, the MCC1 for load flow with a diversity factor of 50% more, it results the calculated voltage drop at MCC1 to go beyond a critical guideline, in this case 5%. You can also export this table to an Excel format to further analyze the results. Okay. So that's basically a very brief introduction about the load flow calculation. Now let's move on to the short circuit calculation. I have introduced, okay, there's someone entering. Let me allow him to come in. Okay. Now the short circuit calculation in ETAP, it allows you to run based on IEC standard, NC standard, or Gauss standard. Depending on your selection, you will have a list of different calculation available. Now I have introduced you the configuration just now. Let me introduce you the presentation as well as the revision in ETAP. This is the presentation that I have for study view, for example. If I want to create another presentation view, I can click on this and add a new one. Say test. This presentation view will be exactly identical with what I have for the study view. Now, sometimes we may want to have different presentation view to represent different equipments or to present equipments that we may want to have for relays. We may want to have another presentation just to indicate all the impedance data within the network. So that's where the presentation comes in. But in this example, I created a new presentation just to show you what happens if I want to make a quick comparison between one scenario versus another scenario for the short circuit calculation. Let me do a quick one here just to change this to duty, for example. And probably I just want to focus on two buses, right? Just want to fault this bus as well as this bus. Just two bus will do. So the same thing for this. Okay, you will see the faulted bus just on the switchboard A and the LV bus number 2. I can run a duty calculations. As you can see right now, duty calculations is basically, it runs according to the standard. Right now, if I choose the IEC standard, it runs based on the IEC 60909 standard. And any violation are color coded. Can you see that these breaker are now in red, and the results are tabulated from the alert view. So if I bring this up, you can easily see that the circuit breaker 16, for example, okay, the braking capability is less than what is being calculated, 8.5 in this case. so that it make us easy to identify the problems, and we can quickly solve the problem by changing the equipment ratings. So this shows the calculation based on normal configuration. Now I'm going to show the transformer ratings here, just just for example. I'll put this up as well. The revision basically allows us to modify the equipment's ratings. In this case, both presentation shows 10 or 15 MVA transformer. Now, for any reason, if you are expanding your system, if you are upgrading your equipment, it is always good to have some revision to manage your modification. So from the test, I probably will add a new revision just to demonstrate how the revision works. So go to create. I can name this like upgrade transformer. And then I can modify. I can go to this revision, modify my transformer from probably we can put just one will do, from 15 to 30, right? So right now I have made changes. I have made
Darren,
changes.
Darren,
Sorry. Yep.
sorry to interrupt you. Let's take some feedback from the client, like if they have any queries or they want to understand something till now.
Oh, okay. Okay. Yeah, sorry. Okay. Um, up to this point, right? Do you have any question? Maybe we can stop for a while. Do you guys have any question in terms of I have shown you the modeling, from modeling all the ways to short circuit calculation.
Okay, I think there is okay.
Is it
Okay,
is
go.
it clear? All
Ya,
right. If
Bapak-bapak
there's no
silakan yang dari
okay,
DLS
let me see
bisa
the chat.
menyampaikan pertanyaan.
Yeah.
Pak Ade, Pak Edo, Pak Fandi, Pak Rahmat, ada pertanyaan?
Pak.
Dilanjut ya.
Pak, masih belum ini.
Okay, Darren, no question. You can continue now.
Yeah. And Darren, just one suggestion, because we have some limited time. We can do more sessions, of course. It would be great that if you can just run through the examples, and at least because the client would be more interested in seeing what is the capability of the module, right? Because how they can model and how they can do all these things, data entry and all, we can definitely do a detailed session. So in my suggestion, it would be great if you can just run the calculations and show the results, reports, and the capabilities of the modules in the essence of the time. Otherwise, you are free to move in whatever direction you are comfortable.
Oh, okay. Sure. Sure. Thank you. Thank you, Ganesh. Okay. Let me quickly move on to different modules. Yeah. So these basically for the short circuit calculations, you can actually run a duty calculation. The duty calculation basically helps us to to identify, or it basically makes some comparison with your equipment selection. If the calculated value is go beyond your selection, it flat out. You also can run 60909. 60909 basically is a calculation for us to look at all the different type of unbalanced fault current, like line to ground, double line short to ground. For example, if I were to open up the display option, you can see the result from the one line diagram. What is the positive, negative, zero sequence for line to ground in this case? So that basically gives us the results according to the calculations. Now, the last option in this case is the 61363. 61363 basically allows us to look at what is the fault current based on time domain. So once I completed the calculation, I can go to plot. We can look at the results at one of these bars here. When I hit OK, basically it shows you what is the, the AC three-phase fault currents, the DC decaying, things like that. Now, the next one is the protection. So I will just quickly go to the protection. Sorry, I think I spent too much time on the front part. The protection coordination module allows us to do three things. One is the TCC view. So if you want to create your relays TCC view, you can simply highlight the elements to be plot.
Darren, no need
Yep.
to rush. No need to rush. No
Yeah.
issues. We can do more session, but whichever thing you are saying, please make sure that that module is covered properly, right? I mean, with the old details. Because we can always do more sessions. That's not an issue.
Okay. Sure.
Sure. Okay. Yeah. And I would request the client's side as well, like if you need to know anything more on particularly on any module, or if you want to
Mhm.
share your requirements, like what kind of projects you are doing and what kind of calculations you want to do, you can
Mhm.
also give us a feedback. We can again do a session in detail, particularly on those modules as well. Please, Darren, go ahead. Sorry. Yeah.
Okay. Thank you. So the coordination, basically we have three parts here. We can create the one line, this TCC view. We can make changes if you want. You can make changes to the relay settings. The fault insertion fault current is also updated from the TCC view. So for selectivity or coordination, if you want to check the time difference against, this is basically how we can actually measure the time between one particular relay and another protective device. So this is basically a TCC view for us to perform our protective device coordination in ETAP. Now, ETAP also provide another tools where, based on the settings or relays we have in this model, we can actually simulate a fault on the system. Like for example, in this case, I put a fault at the motor terminal. So this fault basically calculate the fault current all the way to the motor terminal, and you can see graphically which protective device actually respond based on the fault location. All right. So in this case, it tells us if I have a fault at the motor terminal, the incomer breakers is going to trip first based on this sequence. Now the more advanced features in protection coordination module is what we call star auto evaluation. Now these modules basically allows us to boost our productivity and save time. It basically detecting or the evaluating the entire or a part of the system in terms of protection and coordination based on design criteria or the industry's guideline. So let me quickly show you how it works. I can select this, hit on the auto evaluation. So the program basically run through the calculations, and as you can see right now, it shows the results from the viewer in this case. Clear indications such as green represent is okay, but a red represent it fails. So you can actually modify the settings from the TCC view in this case to re-evaluate the 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 protections. So you can see right now when I make some changes.
Darren, you are muted.
Oh, okay. I'm not sure why. Yep. Thank you. Okay, the arc flash calculations basically look at the PPE requirements, like what is the incident energy. Like for example, I can run in ETAP. We provide these various standards you can choose, like the IEEE 1584. If you have a system more than 15 kV and above, for example, you can also use the arc fault methods in ETAP. So let's look at just one example using 1584 standard. So I will run the calculations. I'll show you the results. And a very quick one, it comes out. The results shows what is the incident energy, in this case 0.7 something. And if you go into the bus editor, basically it gives you more information, more results information from this editor. From here, you can see which breaker actually clear the arcing current, what is the clearing times, and what is the incident energy. The Yep. So against the same thing, depending on which configurations you want to simulate, we have the arc flash analyzer for you as well. So right now I have 3 reports. We can check the incident energy based on worst case scenario. You can generate the label, arc flash label as well from the analyzer. Yeah, it looks something like that. Yeah. Okay, probably I'll just move on to the last one for the harmonics calculation. In this case, ETAP give 2 options right now. The harmonic load flow and frequency scan in this case. Depending on your harmonic source, you can have a harmonic source at the variable frequency drive. You can have harmonic source being modeled in the DC system, like for example, your charger, your battery, your UPS. Harmonic source, yeah, you can pick one even from the library. For example, we have different harmonic source from different manufacturer. So once you have all this, you can actually run the calculations. For example, if I want to know what is the THD at the point of coupling, you can see the percentage THD at this level. You can actually run in ETAP. We also allows you to um, run perform the harmonic filter. So you can also design your harmonic filter based on your requirements. Like in this case, you probably want to design the harmonic filter to be tuned to certain frequency or to achieve certain power factor as well. All right, so you can see right now, if I were to change the configuration to enable my harmonic filter, you will have a better harmonics THD results here at this LV bus. And we can also see the distorted waveform from the plot selection view. So in this case, I will look for LV bus, and then we look at the waveform. Yeah. So it tells us a 3% THD distorted waveform will look something like this. Okay, it's the same thing for harmonic frequency scan. In ETAP, you can run the harmonic frequency scan to check will there be any resonance in your system. So I can run the calculation, go to the plot again, look for bus 2 one more time, and check the impedance profile. So this basically shows you what is the impedance profile at bus number 2 based on the frequency domain. Okay, I would like to stop here for a while. If you have any questions, you're welcome. Yep, right. Okay, 1,500 volt DC. Hmm.
Sorry, gentlemen. I'm really sorry that I joined late. I'll just give a quick introduction. My name is Ganesh Jain, and I'm handling and taking care of all the business and operation of ETAP in the Southeast region. And I'm based out in the regional office in Kuala Lumpur, Malaysia. So you can consider me as your focal point of contact in future for any inquiries on requirements. Just to answer your question, sir, first of all, I believe we already have scheduled one session with you on e-tracks particularly, right? So maybe at that time we have the necessary libraries for the components and the locomotives and other equipments. But just to answer your question over here in this example, ETAP is independent on the voltages and the standards in the power industry. For example, you can run and simulate any network from extra low voltage to extra high voltage, also from AC to DC, either individually, or you can run both of the systems simultaneously in a different modules called time domain load flow, where both of the systems are combined and that can be run together. And in e-track in a traction module, the mostly the system is unbalanced, right? So there we will use unified unbalanced load flow to run the unbalanced AC and DC systems. So, as a capability wise, yes, we have the capability, and I believe once we have a dedicated solution presentation on eTracks, where our subject matter expertise along with Darren will also be present, there you can ask for the libraries for a particular item as well. But just to tell you, we have the locomotive and other DC components available where you can model it right away. Either you can take it from the system or you can build it by yourself. I was being able to answer your question. Okay.
Okay, there is a question from the chat.
Oh,
It
oh, sorry,
says,
I didn't. Yes, you can do that. So basically, there is a module. That's what I was trying to explain. There is a module called time domain load flow, where you can define all the generations and loading categories or loading profiles of a system from 1 day to 1 year or more years. So you can run the complete simulation for the entire time duration that you need, and you can pitch in like on what day or what time, what is your generation and what is your loading. So based on that, ETAP will run the whole simulation and will give you a report on top of it. So yes, it is possible.
that's good. Thank you.
Sure. Any other questions?
What about the first question about can we do short circuit test in primary or secondary windings? Thank you.
Okay, I
You
believe
mean?
this is refer. Yeah, sorry.
Yeah, please
Yeah,
go ahead,
Ganesh,
Darren. No,
sorry.
no,
Just
go
go ahead.
ahead. Go ahead, Darren.
Yeah,
Yeah.
yeah. I believe this question is referred to the fault insertion, right? Am I right?
Uh, I
Uh, uh,
just
uh,
want to
are you
know.
refer to fault at the primary side, something like that? Are you refer to
Windings,
this?
primary windings.
Okay. Um, that's not possible right now for the sequence operation to insert the fault we inside the winding.
Yeah, inside the winding. Okay,
Ganesh,
thank
do
you.
you want to add on to this?
No, that basically that will be reflected at the primary itself, right? So
Yeah, just on the line side.
yeah, we cannot simulate it inside the primary winding. But when we are saying that we are inserting the fault on primary, that means it is on the primary winding.
Yeah, at the primary terminal.
But yeah, yeah, and I believe what you are trying to say is about a vendor operator thing, like when he is doing the testing or manufacturing of the transformer. So in power analysis, we generally perform these short circuit analysis either on primary or secondary or any part of the total complete feeder wherever you want it.
Okay, okay, thank you.
Okay. And one more very unique and very powerful feature which Darren would have explained, and I'm just covering it up because that was not part of discussion. Uh, the benefit of getting ETAP is that it is a one-point solution. It has a strong data exchange module where all the inputs that you can provide to the software, like if you have AutoCAD drawings, you have Revit data, you have GIS information available, right? You have map tiles and any other information available, right? So ETAP can also utilize that and can support to cut down your man hours in the modeling and simulations. Because for example, if there is an AutoCAD drawing available, you can right away import it into ETAP, and ETAP can generate a single line diagram out of it, and similarly you can export it back to AutoCAD as well, right? So there are thousand of there are a couple of other solutions, which maybe I can explain, or I can share it in an email with a nutshell video as well for your reference. And coming on to e-tracks, or any kind of unbalanced network, if you have a GIS network, you can see the unbalanced network in the GIS platform itself. That means wherever you have unbalanced network, you can combine it with the GIS, and you can see the results in the map itself, in the feeder diagrams and all. I mean, that is completely on a bit higher level solutions. So maybe in the further discussions when we'll have, we can explain that and discuss that as well. And I believe all the questions and everything related to traction system, I believe, Darren, when we are having a session, is it next week or next week?
I'm not sure yet. Um, no, yeah,
Okay, because Victor has proposed, I believe, next week or next to next week. So probably in that
okay,
we can take up all of your questions and everything related to traction, where our SME is also present. Because we have
that's
deployed
correct.
couple of projects for e-tracks already in the market, and it would be justifiable if he answers your questions for that. There is a of DC traction panel. I believe we can revert to you on that after checking. So Darren, it is for you to note it down, and we need to check with the SME and revert.
Sure.
Okay, if you have.
Hmm. Okay. This is for the charger. If you want the rectifier, it looks something like that. So the library, we have the sample rectifier for IEC. I can pick this. So it basically shows the AC rating, DC ratings, um, the loading, the VI characteristic, as well as the short circuit contribution to DC.
And just one more point I would like to highlight. In case you don't have a particular model available in the library for your project, you can always request ETAP Help Center where since we are doing projects also globally, and we are keep on developing the library. Sometimes the library is by default available with us, but we always issue the libraries after the validation and verification in a particular release, right? So if that library is available with us, which is yet to be released, we can send it right away to you, or you can ask our team to model that library as well for you. We can take up your inputs, right? And we can develop a library patch file for you and deliver it to you as well. I hope this helps. Mm-hmm. 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 Sir, if you want, meanwhile, till the time we have the next session on the e-tracks with full-fledged presentation and demonstrations, if you want for your team, I can share certain links where you can see how the DC traction system is taken care, or how the combined system is taken care, just for your reference. If that is fine to you, I can share those for your reference. And probably within a week's time or so, we will come up with the detailed demonstration to you for the e-tracks part. Yes. Okay. So what we can do is yeah.
That's
Yeah,
correct. That's
basic.
correct.
Okay.
Yeah, because for this demonstration, basically we look at the modeling. We look at how do we actually do the sizing, equipment selection, based on the uh, configuration, whatever you have. Yeah, but in the subsequent demonstration, we will show you a sample file for the traction system, because ultimately, when you look at the traction simulation, you still need to have the power coming into your traction network. Yeah. So in this demo, basically we look at that. Yeah. Yeah.
Mm-hmm. Okay.
Okay.
Is it possible that you can share some of the information of the project that you are working on? Maybe I can look into that, and I can assign somebody who can, support you on that. I mean, also just not for the project, but for the demonstration of the DC system. Maybe in one more session, Darren, we can take up the time domain load flow with the DC system, DC load flow, DC short circuit, and
Mm-hmm.
the traction, of course.
Right.
Just one question from my end. Are you using any kind of simulation software currently for your day-to-day analysis, like load flow, short circuit, relay coordination? Okay, but that is okay. That's a free software, right? I mean, it has a very basic, limited capabilities. Okay, okay. So, I mean, I believe for any kind of simulations in the system, I believe if you're talking about ETAP, the first step is to have ETAP basic license, even if you don't have, you're not planning for high-end modules. You should be well versed about the ETAP basic modeling, the load flow short circuit. This is the base of every calculation that you want to perform. Without load flow, you won't be able to do the harmonics or motor starting or transient. Without short circuit, you won't be able to do the arc flash relay coordination, right? So these two studies are linked by default. So I believe we'll definitely do a presentation on and demonstration on DC system. So I think the base or the first step would be to have ETAP license to get your engineers engaged with it, and then you can always keep on adding the required modules and solutions based on your project requirements to train your engineers further. So that's it from my end. Darren, if you have anything pending, you can cover it up. Or, sir, if you have any questions, you can let us know based on the things which Darren has presented. And maybe we can meet next time with the traction simulation examples.
I'm good. The rest. All right. If there's no other question, we will meet again next time, and yeah, we'll call you a day for this session.
Okay, thank you for your time.
Okay. Thank you very much.
Thank you, Miss. Thank you,
Thank
Mr.
you,
Darren.
everyone.
Thank you, Mr.
Thank you.
Janish.
Thank you.
Please share the project files which you want us to review. We'll talk our discussions accordingly. Thank you. Bye. Sure. Thank you. Take care. Bye.